And here we have two budding ecologists in their natural habitat. They appear to be studying something quite closely. Let's move in and take a closer look.
Oh, hello. How are you? Well, tonight we're gonna take a little adventure into the unknown world of salmon spawning. So follow us. Let's go.
The study that you're doing about the salmon hatchery, I was wondering why you're doing this study and what it involves.
Well, it is really important to study the salmon because it is essential to supply nutrients such as nitrogen to the riparian habitat such as trees and shrubs. And it also provides food for other animals such as bears, eagles, and that all incorporates into the tourism industry that is all that is Squamish. Squamish is known as the adventure capital of Canada, and salmons are a big part of that.
At the Tenderfoot Hatchery, they take the mature female salmon, kill them, and bleed them. Then they remove the eggs. They extract the sperm from the male salmon and use it to fertilize the eggs. In 2002, the Tenderfoot Hatchery released 1,358,856 Chinook, 459,602 coho, and 791,516 pinks. We aim to find what percentage of hatchery salmon that are released make it back to spawn. After spawning, the mature salmon dies and returns nutrients like nitrogen into the surrounding riparian habitat. The salmon provides food for the eagles, for which Brackendale is famous.
Our objectives?
I would love to know your objectives.
Our objectives were to discover whether or not the hatchery is effective. We did this because by measuring the salmon which lack their adipose fin and the salmon that have their adipose fin, because the hatchery cuts off the salmon's adipose fin before they release them into the wild. So by measuring the returning salmon without their adipose fin, we can determine by correlating this data with the amount of salmon that are released by the hatchery just exactly how effective the hatchery can be.
So what is your hypothesis?
Well, our hypothesis is that the Tenderfoot hatchery has no effect whatsoever on the salmon population.
Now, why do you say no effect?
We do this to maintain objectivity, you see, because if we go in with a biased study, it may affect, and we may come out with biased conclusions.
Interesting.
It's so deep, we can't do anything.
What are we
going to do?
These conditions are treacherous.
Go back.
Could you briefly describe your methods?
Well, our methods are pretty simple. There's 9 main streams which the salmon use when they're returning to spawn. And we counted in each quadrant of 5 meters squared, every 10 meters for 20 quadrants, the number of salmon, dead and alive, that have their adipose fin and that don't have their adipose fin. So we got the total number of salmon, and we got the number of salmon without their adipose fin. We did this for all 9 streams, and we did that twice a week for the whole entire spawning season, spawning cycle, and yeah, we did it for this, and we started at 6 a.m. every day.
The Chinook, chum, coho, and pink salmon in this study return to spawn in the Squamish River and its major tributaries. These include the Mamquam River, Ashlew River, Alaho River, Cheakamus River, Tenderfoot Creek, the Indian River, 36 Mile Creek, and Shot Creek. Salmon spawning occurs between October to December for chum, November to January for coho, September to October for pink, and August to September for Chinook. Our study will take place between August and January, where we will count the number of salmon that have returned to spawn. We will make our observations within 20 5-meter squared quadrants spaced at 10-meter intervals along each of the most active spawning sections of the Squamish River and its tributaries. Sampling will take place throughout the entire spawning cycle, twice per week, and will begin at 6 a.m. each morning. Results will be separated into salmon that lack their adipose fin and those that retain it. We will compare the number of salmon that lack their adipose fin with the average number of salmon released from the Tenderfoot Hatchery in the last 2 to 7 years. Note that decomposition of dead salmon may make adipose identification difficult or impossible.
The y-axis of this graph represents the number of salmon released by the Tenderfoot Hatchery. The x-axis shows the year in which the salmon were released. This historic record will help when taking into account how many salmon were released on average within the time it takes for each species to mature. We will use this information later to calculate the overall success rate. In our set area, we will count the number of salmon with and without adipose fins. The number of salmon without adipose fins represents the number of returning hatchery salmon. We will correlate this data with the number of salmon released to find the overall success rate. We will do 10 graphs, 1 for the Squamish River and 9 for each of its tributaries. The number of salmon released from the hatchery would be the average amount released over the period of time it takes for a salmon to mature. We would have separate graphs for separate species of salmon, therefore the number of years until maturity would be different. The number of returning salmon would be the number of salmon without adipose fins. From this information, we could calculate the percentage of hatchery salmon that survive from release until maturity.
Well, this has been a great interview.
Hard workers.
Yeah?
Dedicated.
Any last words to your adoring public?
Well,